No hablo español, no entendió. Benvenido en la sesión 3 micro. Well, I will switch to English. Really, I'm just trying to impersonate somebody who can actually speak English because I'm French. So basically, French is very close to Spanish, but I cannot talk at all. Sorry for this poor attempt at speaking Spanish. So thanks to be here for this session about how you can improve your microservices architecture. I'm Nicolas Frankel. I have been a developer, or I've been working in technical role for about 17, 18 years. And nearly 2 years ago, I decided to do some developer advocacy. So more about doing fun demo and stuff like that. Because when I was doing technical roles, I always worked in, let's say, at least middle-sized companies. So I'm pretty used to enterprise tax, and I will demo that in that talk. I work for a company called Hazelcast. Hazelcast has two products. Hazelcast IMDG, basically I will be using it, so I won't dive further. And we have another product called Hazelcast Jet. And Jet basically leverages Hazelcast IMDG to do in-memory stream processing. So if you have like very fast data pipe processing needs, that needs to be very fast, just as fraud verification, for example, in banking, then Hazelcast Jet might be a good fit. So microservices, I believe everybody wants to do microservices. Everybody does microservices. A couple of years ago, that was actually the credo that everybody should do microservices. Now it's getting a bit better. Like people are like finally realizing that might not be so rainbows and unicorns. But still, a lot of people are trying to do it because of the benefits. But the issue is, in order to get the benefits, then you need to go through a couple of constraints. And Martin Fowler, on his website, when he tries to define what are microservices, he goes through all those steps. And basically, in general, the first few are very easy because they are basically very technical. But in general, at the last step, then you have an issue because most organizations, they still have a budget when they are doing projects. So you have a start date and you have an end date, and you have a sum of money that you need to spend between this start date and this end date. And if you are doing this kind of stuff, if you are doing projects, basically you are not doing microservices. It doesn't stop you from doing web services, which is still good, but you won't get all the benefit of microservices. So this is just a word of warning. Probably you are not doing microservices. I am not doing microservices, and not a lot of companies are doing microservices. But if you are doing microservices, one of the benefits is basically scalability. And when I'm talking about scalability, I'm not talking about performance. I will go toward that in a few steps, but basically that means that to increase your performance at some point, you will do what you will do is you will add more memory, more CPUs and whatever, and you will scale vertically, but it has limits, and the limit is based on the operating system. Some operating systems are much better at managing hardware than others, but in all cases, you will hit the limit. So the next step is to like scale horizontally. And once you start scaling horizontally, you notice that if you scale horizontally your monolith, then all the features of the monolith will be scaled equally, meaning that I'm using always the same microservices architecture example as an e-commerce. So imagine you have an e-commerce architecture and a microservices for browsing the catalog, and you have a microservice to log in, you have a microservice for the cart, you have a microservice for the checkout, you have a microservice for the payment. And basically this is a funnel. So you will have like perhaps like 100% browsing the catalog, and perhaps 50 are going to log in, and perhaps 20 are going to put stuff into their cart, and perhaps 5% are going to the checkout, and 1% are going to pay. And if you scale horizontally all those features, well, basically you will be scaling for the catalog browsing parts, and the payment will be scaled, but it won't be used. So it's not very, from an engineering perspective, it's not a good idea. So having definite microservices allow you to scale those features independently, so you can scale the ones that are most used, such as the catalog. And now I have a question. Of course, since it's not a real conference, it's virtual, I have no way of knowing your answer, but I will give you a few seconds to let me know if you spot a difference between those two diagrams. So on the left, you have a component A. On the right, you have a component A of type A that calls a component B of type B. I give you a few seconds to check if you can spot the difference. So I will answer, and if you have been working in enterprises, if you have been working with architects, basically the architects, for them, these are the same diagrams that they use to model the reality, but on the left side, they will model that as an API call inside your JVM. And on the right side, it will be a microservices call, and it involves the network. But from a UML perspective, that you model it the same way. And that's where the problem is basically from an architectural point of view, it's the same. But if you are a developer, that it's not the same, because on the right side, as I mentioned, you are using microservices, and congrats, now you are doing distributed systems. And distributed systems are hard. And the real problem is once you start going through the network, you will actually decrease performances. Because if you are doing like 1 millisecond a call from your component A to your component B inside the JVM, then it might be 1 second, half a second in a network call. And it's only from one service to the other. Now, if you stack them up, it's going to be horrible. And I'm not even talking about all those fallacies of distributed computing. And the first one being that the network is reliable. Like in a traditional JVM, your component A calls component B, and either you get the result or you've got an exception. But in distributed computing, your component A might call component B and have nothing at all. And it's worse because the component A doesn't even know if B was reached, and that the answer, the response didn't come, or if it never reached. This slide should be printed. It's not from me. You can go to your logical fallacies. And you will see that it should be put in every office. So if I try to model the UML diagram in a better way, this is probably something like that. Layer can be the network, can be your framework, can be a lot of stuff. And if I model everything, I need also to account for the response. Now you can see microservice architecture, then you're going to be very, very slow. And if you have a bit of experience, if I tell you, hey, something is slow, then probably you will say, oh, I will need some caching. So the first thing to know is basically, you must remember that caching is a trade-off. And the trade-off is you will be faster, but your data won't be as up-to-date as the normal call. So that's something to remember. It's a trade-off. In most cases, the trade-off is a good trade-off. You are happy about it. Still, it's a trade-off. You won't have the latest data. So if I tell you about caching, probably in your mind, you think about this stuff. There are two hard things in computer science, cache, and of course, when you start thinking about caching, you want to use a hash map because, I mean, I'm guilty of that as well. Thing that I did in the past when I had to cache stuff was to use a hash map. But please never, ever do that, never. Like, the problem with Hashmap is it's unbounded data structure. So it can grow and grow and grow and grow, and basically you can have out of memory errors because the Hashmap will take all the memory. So you must always think about an eviction strategy. So first put a limit, and then if you need to add an additional entry and the limit has been hit, then you need a way to say, oh, I will remove this one to put this new one. It can be the least recently used. It can be the least used. There are a couple of strategies. And also, as I mentioned, cache invalidation is hard. So when you put something into the cache, you must think, how long should it be there? How long should it be valid? So this is the kind of features that caching providers provide you out of the box. Even if it's not Hazelcast, you should always use a professional solution. There are some open source free solutions, please use them. Which brings me to my point. Hazelcast is an in-memory data grid, and what is an in-memory data grid basically is just a distributed object store. And the most used one is, of course, the map. And when I say distributed, imagine, so instead of having the map, which sits inside the memory and all the map entities are inside this one JVM, then you have several nodes that are distributed across the network, and you can decide that some of those entries, they are replicated, or it can be even sharded. So if you have a lot of entities, then you can decide, oh, I don't need to have all of them inside this one node, so I will distribute them among the network. So we have queues, we have lists, we have a lot of different data structure. In this talk, I will just mainly use the map because even already with the map, you can do a lot of stuff. So now that we are agreed that we will use caching to improve and our reliability, I will show you 3 use cases. The first is not related actually to microservices, but I think it's a good thing to do it anyway. So it will be how you access your database. The second will be doing HTTP calls, and the third will be about session data. First, I guess that a lot of people here know about Hibernate. It's like an age-old object relational mapping, quite widespread in Java, and it has been a GPA implementation for a long time. And probably you've come up with caching in Hibernate. So the first thing to know is basically in Hibernate, there are 2 levels of cache. The first cache, the first level, is implemented by default and is related to the session object. So if you have a session and you make a query and you make the same query with the same session object, then basically you will read from the cache, but the cache of the session object. And that's good, but in most scenarios, the session object is only used, let's say, once. Because what happens a lot is you make an HTTP to your, and then the back return the result is serialized in HTML or whatever, and session is destroyed. So basically this cache is in general is automated, but it's used generally only once. So only if you make several requests with the same session object, which normally you shouldn't do, you should try to do only like one query, not do one query, get the result, and then do another query with the result. Only in that case, the cache might be reused, but it's not a good idea either way. However, what you can do to improve performance is to use the level 2 cache. This one is not enabled by default. You must enable it yourself, and more importantly, you must configure it yourself because it relies on third-party implementation. And the cache is read through. So basically, if the cache doesn't contain the key, it will load it from the database, put it in the cache. And if the cache contains the key, it will return the value. And write through is when you will write to the database and create or update the value. So now it's time for a demo. And here I've created a project. It's a Spring Boot project actually, but you can do the same with without Spring Boot. You can do it with Java, you can do it with whatever you want as long as you are using Hibernate. And you can see that the Hazelcast, I'm using H2, so this is not a great use case because actually H2 is an in-memory database. So putting an in-memory cache in front of an in-memory database doesn't improve the performance that much, but I mean, it's just for the sake of the demo, and that's all. So here I have a person controller. So this is the equivalent of a JAX RS endpoint. You can understand it, I believe, even if you have never written any Spring Boot. Here I have a request mapping that is /d, and here I have a get mapping. So basically I can request all the persons, or I can request one person by its ID. And below I have a person repository, which extends GPR repository. And basically the good stuff about that is at runtime, Spring will create for me the implementation. And right by default, I have a couple of default methods. So for example, I have this find all or find by ID by default. Because I'm using Spring Boot, I can create a data SQL. So at the start of my application, it will run those queries. So basically here I will have 3 entities, and I have configured Hazelcast to have this database map. And that's not very old. Here I also need to configure Spring Boot, and the Hazelcast related stuff is this one. Here I use the second level cache. Here I use a query cache. Here I set the factory class for the read, and I will be using with here Hazelcast instance, which will be this instance. And that's all that I need to do. Now I start my application. We can see here that Hazelcast has been started with 1 member, so it's not distributed across all network. I will demo a cluster of stuff in my last point about session replication. And here, what I have enabled Hibernate statistics to show you how Hibernate will use the cache. So here I didn't do any requests, so of course nothing has happened so far. Now I will be doing the code, and I have an end 8080/d/ the first entity. It returns me the data, and we can see here that the statistics say, hey, we had 1 miss, and because of this 1 miss, we did a put. So right now, the cache is as this one entity, but before it was empty. So it had to go through the database and execute this statement. And now, if we do the same request again, the statistics says, hey, now we have a hit, and we didn't do any statements. So now everything happens in memory. We don't go to the database. Caching, improve performances. And of course, what you can do is you can get all like that, JQ, because it's better. You can see it better like that. And if I ask for the third entity, then there is a hit. So now I have all my database in the cache, and every time I query one, basically it won't go to the database. That's pretty cool, but that's sadly not enough. So we can do better. We can go further. If you want to be even faster, what you can do is you remove Hibernate and you use Hazelcast as your data store. And then you can have listeners that will write to the database in an S. Of course, in that case, you are very, very fast, but there is no guarantee. So basically, you are saying, hey, I will send stuff to Hazelcast. And at some point, the async writer will work its magic and something will happen. This is eventual consistency. But meanwhile, if, I don't know, you have like a poor search that crashes all your nodes, well, you have lost data. But you are very, very, very fast, which is another trade-off to be aware of. So it's an alternative. I'm not saying you should do it, but you should use the right tool. Now going to HTTP, we could cache actually manually, but I believe that if you have an API, you should always go through the API. And there is a Java API for caching actually, and it's called JCache. You have one specification and you have multiple implementations. Some of them are distributed, some of them are not distributed, but in all cases, and I believe this is a really cool stuff. And getting back to my e-commerce architecture, I would really, really recommend thinking hard and long about that, about caching. I mentioned that the trade-off was having the right data and having the data fast. And in a lot of cases, engineer will say, oh, but we prefer to have the right data. We prefer to wait a bit. But think about it. Think about this e-commerce microservices architecture. And think, for example, about the pricing service. So when you put stuff into your cart, you have some price. When you do the checkout, you have perhaps another price. And every time you call the pricing service, because the pricing service tells you the price at this time, and perhaps the price I changed for, I don't know, because there was a discount, because the business want to sell more stuff, or because I don't know, the stock is too much, or for whatever reason. And you will say, oh, but we want this price. This price is really necessary. Otherwise, we won't be able to sell at the right price. But if you put yourself in the shoes of the right price is not that important. In e-commerce, you want to sell at all costs. So even if you lose a few cents on each sale at some point, then perhaps at another point you will gain a few cents. And in the average, you will be middle. And more importantly, you will have sold. Because if it takes too long to wait for the price, a lot of customers will go away and won't buy at all. So in e-commerce, you want to sell at all costs, and it's better to sell at the wrong price than not to sell at all. And I believe there is a lot of contexts, which I don't know. I've worked in e-commerce, but I've not worked in every industry. There are a lot of other industry where this applies as well. So when you think about that, please go to the business, ask them, hey, do you really need that? What is more important? Is it to be fast or to have the right data? And in a lot of cases, of course, the business will say, hey, we want both, because they are business and they want everything. But if they need to choose, in a lot of cases, they will choose to have fast instead. Do some Git. Oh yeah. I showed you how you could configure Hazelcast in XML, but we also have a Java API for that. So this is the equivalent of the XML formally. We also have YAML configuration if you prefer YAML. I mean, everybody decides. So here what I will show you is direct string integration, because basically it goes like that. You have Spring Cache, and then you will have the Gcache implementation, and then you will have Hazelcast. So instead, I prefer to have just Spring Cache and Hazelcast in the implementation. It makes no sense to have an abstraction in the middle. So I've created this proxy controller, and what this proxy controller do is instead of using the repo directly, it uses a caching service, and this caching service is using the cacheable annotation from Spring, which is very, very similar from the annotation from Gcache. And we just tell it, hey, use this map, and now we have a new map that we've configured. If I go here, so we have this new service map, and basically here it will know that it needs to put ID as the key and this person as the value, and afterwards it gets the repo. Oh, I have a question. Unfortunately, as I mentioned, I don't speak Spanish. So perhaps somebody at the end will be able to answer, to translate it for me. But right now, I'm not able to answer the question.
Okay, okay, at the end, I can translate that. If you want it now, I also can do it. It's up to you.
Oh, please do it. I mean, I prefer interaction. So by all means, everybody ask your questions.
Okay. The question is it's an anonymous attendee, so I don't have the name, but it basically says, what will be your recommendations for migrating one application, a monolithic application based in AGB3, into an architecture targeting microservices?
That goes a lot beyond the scope of this talk, but the first, I mean, if I were to work at your place, first I would ask, why would you want to migrate? So what is your requirement? Is it working? If it's working fine, then why would you migrate? That would be my first question. You might know about those 5 whys or 3 whys. So if somebody asks you a question, you ask why, and if answer you go the why deeper, because I would have no recommendation. I mean, I have no context. So I must understand why there would be a need for migration. Is it to do like everybody? Is it, and then if it's to do like everybody, then why would you like to do like everybody? Because everybody is not who you think. Google has microservices, Netflix has microservices. The big companies have microservices, but they also have the skills, they also have the infrastructure, they also have the experience. If you're a middle-sized business, in most cases, I would say keep your EGB3 monolith application and be happy if it works. Don't touch it. So that would be my answer, which of course is not the answer that the attendee was looking for, but unless I know more, I just say don't touch it.
Awesome, thank you. You can go. We don't have any question. Recuerden, amigos, amigas, que pueden ir anotando sus respuestas y al final de la charla las estaremos traduciendo si las ponen en español. Thank you.
Yeah, like the gentleman said, en español or in English. Better in English. Anyway, so here I have this person controller. I was not on this one. I have on this one, on this proxy controller. I'm using a caching service. The caching service itself has been annotated. So basically, I don't need to touch the cache myself, just as with Hibernate. I just need to configure it, and configuration is done through here. Here, I just create a new Spring Cache Manager that wraps the Hazelcast Cache Manager, that wraps the Hazelcast instance that I created just here. So I will stop this application. And now I will curl it, but here I have another endpoint. So it's R. And it does the thing. But now how can I prove to you that it's actually using the cache? So what I will be using, so far, all that I've showed you is open source. Now I will show you something that unfortunately is not open source. It's part of our enterprise offering. So I will be using what we call the management center, and basically it's a console for Hazelcast. And I will show you how you can use it to show that actually you are using the cache. So here I will be using localhost. Yes, this. And it asks me about my login and passwords. And here you can see here that because it's not clustered. And I have already 3 maps, the database one, the one used by Hazelcast. This is an internal proprietary stuff. And here, this is the service that I configured. And perhaps it's a bit small, so I will make it a bit bigger. And here you can see that I got 1 get and I got 1 entries. So now if I call it again through this, I should have 2 gets and still 1 entry. Takes a bit of time. Yes, I have 2 gets and 1 entry. And basically, I'm not touching the database at all. But of course, since I'm already using the Hibernate level 2 cache, I cannot prove you that just by looking at this, the Hibernate statistic that I'm not using it. So here I have 2 gets, and if you see here, I have 1 hit. Basically, the cache was empty, so it put it into the cache. And the second one, I've got 1 hit and 2 gets. If I can do it once more, and you will have 3 gets and 2 hits. Yes, 3 gets and 2 hits. Now, if I try to read a new entry, so basically I have the key number 1. And it takes a bit of time, but you will see the number of entries going up here as well. But it's a bit slower, of course. So this is what you can do. And just for the record, if I not because I was lazy, but because basically if I got the lists, there is no way that the Spring framework can decide when you return the list what key will be used to put all the entries. So far there is a closed issue here, and basically you can implement it yourself, but they won't put it in the Spring framework. I have a second question. Is the cache layer in an application the best choice than API gateway cache or other service cache solution? That's a very good question. The answer is it depends. If you add another dedicated piece of architecture, it's a good idea actually, but it's one additional moving part. So it much integration, how tangled you want your architecture to be. And again, it's an open question. Here, I have less an opinion than the previous one. I would say it depends a lot. So it depends on your context. For example, you might be already using Hazelcast, and then you can just create, because the organization lets developers or lets administrators create new maps very easily. So it's a no-brainer. Now imagine you are in a bigger organization and you don't have this gateway. And so that means that actually you will need to, like, let's say, pester your manager for a long time, and then he will pester his manager for a long time, and so on and so forth. So it depends a lot on the organization. What are the benefits of using it here? So what I showed you is also the cache is on the JVM itself. So if you have a gateway cache, that means that the cache will be externalized, and you will still need to access the gateway API cache. Might be too much hurdle for you. It depends. Does it work with reactive CRUD repository? It works, yes, but I need to write an article about that. You cannot just annotate it. So basically, you would need to have an additional step in your pipeline to say, hey, and put it in the cache or take it from the cache. And if it's not in the cache, then use it. So it's a good question. I need to write it. Just follow me on Twitter, and when it's done, I will be happy to tweet it. So yes, but it's much more troublesome than just annotation with imperative programming. And I have a question in Spanish. La cache se puede aplicar al nivel de sesión y a nivel de aplicación. So let me try to translate it with my bad French. So the cache.
I can help with that.
No, let me try. It's fun, really.
Okay, perfect.
Can the cache, is the cache applicable at the session level or at the application level? Is that correct?
That's correct.
Yes. You see, with French, I can understand some stuff. Here, I showed you, but nothing prevents you, and I will show you how you can use it at the session level just in my next section. So for now, it's just for the application. But again, for the session, just wait a bit and I will have a demo about it. So I switch it off, and here I switch it off, and here I switch it off because it's switched. Of course, it doesn't find it anymore. So the last point that I want to bring is session data. So in non-trivial customer-facing application, probably you have more than one application server or servlet container. You probably have multiple Tomcats, WebLogic. To balance them, then you probably have, let's say, a load balancer, a web server in front that serves as a web balancer. It can be Apache, it can be Nginx, it can be anything. The thing goes like this. When the first time there is a request from a machine, it goes through the load balancer. The load balancer has a strategy. It tells, hey, I will be using round robin. I will be using the one that has the least connection. I will be using whatever. And it directs you to one node. And probably there is a high chance that you've got some session data inside of it. So it can be just a login. If you log in, then probably you have a session cookie with, well, your ID. But probably you would want to put more stuff in your session. And now the problem is if at the next call, then the load balancer directs you to another node, then you will have lost everything. So if you think this is, again, an e-commerce application, then you will lose your cart because your cart is probably not in the database. You don't want to put the cart in the database because every time going to read all the database to have cart info is too much. In general, you put cart data in the session. So if you go to another node, then you will use your cart. And of course, that's not acceptable. So in order to cope with that, then there is something called sticky sessions. So once you have been set a cookie, then the load balancer, it knows that this session is associated to the first Tomcat. So every time you do a new request, then it redirects you to this Tomcat. And so you keep your session and everybody is happy. You still have your cards and Amazon can sell you stuff. But we are living in a very dangerous environment. And at some point in time, this node will crash. It can be a normal shutdown, it can be a real crash, it can be a network partition that this load balancer cannot access this Tomcat, it can be anything. So what does the load balancer do? Well, it will probably direct you to another Tomcat, and you will lose your session data again, and that you want to avoid. So you want to keep that in memory as much as possible, but you want to keep your data available and to balance that data to other nodes if it fails. Is there any standard? So we saw there was the Hibernate, which is like a de facto standard. We see there was JCache or Spring. And is there a standard for that? And no, there is no standard. We want the session data to be replicated across all nodes on the cluster. But Hazelcasts can help you with that as well, because we have different integration points. So we have a solution that is solely based on filters. We are a Spring Session integration implementation. We have a direct Tomcat integration. So either directly on the Tomcat or through Spring Boot embedded, if you are using those like self-executing jars that embeds Tomcat, and the same goes for Jetty. So this is my last demo. And in this demo, I will show you how to do session replication. So I have a session, what I call a session data controller. Something called a session data handler to get the HTTP session and to ignore. And this session data handler basically and use what I call a session data. And the session data is basically a key, which basically will be the session ID and a counter. And so I have created a HA proxy configuration, and I will be doing round robin. So if I have no session replication, the first call will go through node, let's say 1, and it will get me a counter of 1. And if I do a second request, since I have no sticky session, since I only have round robin, then it will go to the other node and it will return me 1 again. And then again, I will go on the first node, it will get 2 and 2 and 3 and 3. Now, if I session, I will ask on the first request, the first node, it will return me 1. And because the session is shared across both nodes, if I go on the second node, on the second request, it will return me 2 and 3 and 4, just as expected. And how do you configure it? You configure it like that. So this is Spring Boot stuff, but basically here I've been super lazy, but you can do the same with XML. It's just a bit harder to do. This is all you need to do, all those lines. So basically you add to the Tomcat context, you add a customizer where you create a session manager. You can, here in normal circumstances, you would say set sticky true because you want sticky. Improvements, stuff that here we need to make sure that session has been replicated and stuff. You wouldn't do that if sticky sessions were enabled. But here, because it's a demo, I set it to false because I have this stupid round robin. And you just say, hey, I will be using the Hazelcast instance, which I've described here. And I will be using the manager on the context. And that's all you need to do. And
Nicolas, sorry for
yes.
interruption. We are just at the
Yes.
top of the 48 minutes. So you can take a couple, 2 minutes or extra to wrap up. And
sure.
Yeah.
I will just do the demo because I think it's super cool, but I will be very, very fast. Docker compose up. Here, my Docker compose, it consists of management center, but I won't show it. And then here, so if I do refresh, if I refresh, and if I have session replication, I go on another node, but still it increments it. So this is so cool. Now, wrap up. If you want to do microservices, you will get scalability, but scalability and performance are not the same. So basically, if you go to microservice, you will actually lose a lot of performance. And then you need to add more hardware, horizontal or vertical, but at some point vertical, you're limited. So you need to do horizontal scaling and you lose performance. Caching can help you with that, but you must understand that the trade-off is still data. And IMDG has several integration points for caching across different areas. So we have seen database access, we have seen HTTP calls, and we have seen session replication. So thanks for your attention. You can read my blog, you can follow me on Twitter, you can check hazelcast.org. And if you're interested to go deeper into the demo, then you can go on this repo, it's on GitHub, and it's completely open source. Thanks a lot for your.
We have one last question, really quick one. Can you share the demos? People is asking where they can find them.
Here. This is the repo. Basically, you go here and it's on GitHub. You just copy paste. And it's here and you can find everything.
Awesome, thank you. Okay, so le damos las gracias por habernos acompañado en esta sesión y agradecemos también la colaboración de todos ustedes. Les recordamos que en la UC.org está la agenda de todas las sesiones. No dejen de revisarlas. Y thank you again for your time, Nicolas. Yeah, my kid is the one screaming at the back. But thank you much for sharing all the knowledge that you have, and looking forward to see you around, hopefully in person for the next iteration of the tour. It was a great session, and we may close the Zoom now. Thank you much.
Muchas gracias. At least in my case, because it's the evening. Have a good.
Awesome. Bye-bye. Thank you. Okay, thank you much. I'm gonna stop recording. Okay. See you, Nicolas. Thank you.
Thanks a lot. Sorry for the lating. I mean, I didn't see the time. I was feeling comfortable. People were asking questions. Really great stuff.